Here's quite a tricky differentiation question, but it actually gives an insight into how differentiation is used, albeit in a very simplified setting. A farmer wants to make a rectangular pen for keeping sheep. Okay, you wouldn't use it for this particular circumstance, but anyway. He uses a wall AB for one side. For the other three sides, he used 28 meters of fencing. This is actually a typical A-level type question. He wants to make the area of the pen as large as possible. So what he says is he's got this pen here. It's X width. It's 28 minus 2x, and he's used fencing along these three sides. So that side, and that side. So that's all the fencing he's got. The length parallel to the wall is 28 minus 2x. The area of pen is y. Show that y equals that. Well, to work out the area of the rectangle, basically all it's saying for you to do is to say that y, the area, is equal to the width times, okay, sorry about that. Let's try that again. Y is equal to the width times the length. And that, of course, equals 28x minus 2x squared. It then says find dy by dx. Well, if we differentiate anything with just x on the end, it becomes that number. So we're going to get 28x becomes 28. X squared becomes 2x, so minus 2x squared becomes minus 4x. So let's find the value of x for which y is a maximum. And this is probably the point where people start to panic. Okay, if you want to find a maximum or a minimum, it's at a point where the gradient of the graph equals 0. So if you have a graph doing this, at any point where it peaks, the gradient at that point is 0. So that would be a maximum. That would be a maximum. You can have more than one maximum instantly. Maximums are just where the graph at that point peaks. It doesn't mean the maximum value of the graph. And similarly, here this is at the bottom, so that would be a minimum. Here this is at the bottom, so that would be a minimum. So the way you find them is it's the point where the gradient at that point is 0. dy by dx tells you what the gradient is. So you're just finding out where the gradient equals 0, i.e. where 28 minus 4x equals 0. So if 28 minus 4x equals 0, then 4x equals 28, and x equals 7. That's it. That's what you need to know. How do you know that this value gives a maximum? Well, this is a common type of question. It asks you how you know what type of graph you've got. Well, it's a quadratic because it's 28x minus 2x squared. That's the original function, not the gradient function. The original function is 28 minus 2x squared. It's a quadratic because the highest power of x is x squared, and it's a negative quadratic. That is to say, the number in front of x squared is a minus 1. It's minus 2x squared. So a negative quadratic means that the point where the gradient is 0 is a maximum. We can write that in full. You could just say negative quadratic gives rise to a maximum, but I'm going to write it as negative quadratic means there's a maximum of dy by dx equals 0. Similarly, if it were a positive quadratic, you'd have a minimum when the gradient equals 0. And this is the other really tricky part. This is probably the bit that very few people really understood what they were getting at. The largest possible area of the pen. Right, you just plotted y is the area of the pen, right? And y will increase with x and then decrease with x because it's a negative quadratic. It's going to go up a bit, and then it's going to go down a bit. Not necessarily symmetrically. Well, actually, it's going to be symmetrical at this point, but anyway. So yeah, after a certain value of x, you would actually end up with a negative area. But let's not go into that for the time being. But yeah, so as x increases, y will increase up to a certain point because it's an upside down quadratic, and then it'll go down. So if y is the area, what point on this graph represents the largest possible area? What's the largest value of y? The largest value of y is at the maximum. Yeah, when we differentiate y, we find the gradient function. We make the gradient function equal to 0 because it's a negative quadratic. That tells us the maximum of a curve. It tells us where the peak value of the curve is. So if the curve is the area, the peak value is the biggest possible area. Now that's a difficult concept to get. I hope you understand that, because having got this, we know that the maximum possible value of y occurs when x is 7. So to work out what that value of y is, we stick 7 back into the original equation, 28x minus 2x squared. So we get y, the maximum area equals 28x minus 2 times x squared, and we get 98. Okay, now that's a difficult question, but you do sometimes get questions of this form where you have to find the maximum or the minimum, explain how you know it's a maximum or minimum, and then find the consequent largest possible or lowest possible value of y. So go back over this video if you need to and ask me if you're stuck.